Well, hi everyone. Today we'll be working on graphs of parent trig functions, and I'm just going to draw this here a little bit. And the first trig function I'm going to deal with is sine. And f of x equals sine of x. Or we could be thinking of it as theta also. F of theta equals sine of theta. And I'm going to, first of all, I'm going to make this 1 and this negative 1 on the y-axis here. And I'm going to split this up and go by pi over 2. 1 pi over 2, pi, 3 pi over 2, 2 pi, okay? And if you, I'll just go right off our unit circle here. If I am graphing sine, that's the y-coordinates here, and the sine of 0 is 0. The sine of pi over 2, I think you'll see, is 1. So I'm going to put a point up here. Sine of pi is 0. Sine of 3 pi over 2 is negative 1, and sine of 2 pi is 1. Okay, and let's make a nice pretty sine wave here, or sine curve. Okay, now that is one period. Okay, if I were to go next to, this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. If I go 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, 8 pi over 2, which is 4 pi. If I go another period, I'm going to change colors here. 2 pi, the next pi, that's up here at 1 again. And it comes back down at 3 pi, it's over here, it's at 0 again. At 7 pi over 2, it's negative 1, and at 4 pi. So here's another period of it. I got fancy and changed colors on it, of the graph. But I really want you to see, we start at the origin and we come up and then we come back this way. And then if I went in the negative direction, so if I were to go negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, at negative pi over 2, we are at negative 1. So I'd have that point. At negative pi, we're back at 0. At negative 3 pi over 2, that's up here, we would be at 1. And negative 2 pi would be back at 0. So we kind of go like this. And so that is this is just the parent function of the sine function, parent graph of the sine function. All right. And I'm fumbling through here for a highlighter because I really do want to highlight just that first period. Okay. That's the first part from the part that the unit circle gives us. All right. And after that, it just starts repeating itself. It's like we have a stamp here, and we can stamp it and just keep stamping it over and over this way too. Okay. So what I want you to notice is when I talk about period, how long does it take before it starts repeating itself? well, from 0 to 2 pi, the period is 2 pi units long. Every 2 pi units it repeats itself. The amplitude is another term I want you to have on the handy. And the amplitude is from the middle, the midline of the graph, unto the peak is 1 unit, or to the bottom is 1 unit. The amplitude here is 1. So those are terms I want you to be familiar with. The period and amplitude. Okay, this is A for amplitude. From here to here, that is the period. Okay. Now, the second function we're going to do is cosine. F of x equals cosine of x. And what I'm going to use here is the same basic grid. Okay, and pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. Wow. I'm going to stop at 2 pi first. I'll go ahead and, since I see it up here at the top, 3 pi, 7 pi over 2, and 4 pi. And then on the negative side, this is 0. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, now cosine of 0 is 1. And I'm going to make 1 here and negative 1 here. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. Whoops. That's not there. That's there. And cosine of 2 pi comes back up to 1. So this one kind of comes out like this. And if I were to use this circle like for the 45 or something, I get a point there, and you kind of see how this, and it comes up and then comes back up here. All right, and I'm going to highlight this first now. This is kind of the standard cosine curve. I want you to remember this shape for cosine. I want you to remember this shape for sine. And then it repeats itself. If you go to 5 pi over 2, this is 4 pi over 2, this is 5 pi over 2, we're back down to 0. You go to 3 pi, you're over here, you're back at negative 1. Then you go back up to 0, and then you go back up to 1. So and negative pi over 2, you're at 0. Negative pi, you're at negative 1. Negative 3 pi over 2, you're at positive 1, because it's the same as pi over 2. And then it back, I'm sorry, you're at 0 here. Oops. You're at 0 for the x coordinate. And then you're back up to 1 here. And away we go. All right, and the period here is still from 0 to 2 pi. This is the repeatable length here. That's the period. The amplitude is 1. Okay. We are now going to do f of x equals tangent of x. Now this one's going to have asymptotes. Means there's just part of the graph that will not be touched, and will be approached but not touched. So I'm going to draw this out a little more here. And this time I'm going to scale it a little differently. I'm going to go by pi over 4, pi over 2, 3 pi over 4, pi, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, 8 pi over 4, which is 2 pi, and 9 pi, well, I'll stop there. I'll stop at 2 pi right now, but I will go negative here a little bit. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative 4 pi over 4, which is negative pi, negative 5 pi over 4, negative 6 pi over 4, which is negative 3 pi over 2, negative 7 pi over 4, I may not do this many, or negative 2 pi. All right. Now, where's that? Okay. We're doing tangent. Remember, tangent is sine over cosine. All right, so right here I got 0 divided by 1 is 0. Now pi over 4 is square root of 2 over 2 over the square root of 2 over 2, and I'm gonna scale by ones on the lines, 2, 3, 4, and so on. So square root of 2, okay, this is the point on here. What I want you to think about here is that pi over 2, 1 divided by 0 is undefined. The tangent is undefined at pi over 2. So that's where, I'm going to change colors here. Actually, I'm going to go to a pencil here. I am going to, this is not part of the graph, but it is an asymptote. At pi over 2, we don't quite hit, we're not going to hit the graph. That happens again at 3 pi over 2. That's negative 1 divided by 0. We're not going to hit this graph here. And then if I go in this direction, negative pi over 2, that's the same thing as this one. I'm going to draw another asymptote. Negative 3 pi over 2 is 1 over 0 as well. Okay. So what I want to deal with first is this part right here. And at pi over 4, it's square root of 2 over 2 and square root of 2 over 2. At negative pi over 4, it's negative square root of 2 over 2 over the positive square root of 2 over 2, which is negative 1. So right here is negative 1. And what happens is, this is going to be really close down here, and it's going to come up toward this 1, circle back here, come up here, and curve up toward this asymptote. If we were to be a little more precise with some of these other values, you would see that the closer we get to pi over 2, the higher we get. But remember, it's undefined at pi over 2. Okay. Now, I'm going to next come over here and at 3 pi over 4, 3 pi over 4 is right here. It's positive square root of 2 over 2 over negative square root of 2 over 2. All right, 3 pi over 4, it's negative 1. At pi, it's 0 over negative 1, which is 0. At 5 pi over 4, it's a negative square root of 2 over 2 over a negative square root of 2 over 2. That's 1. Okay, so if I draw this next one here, it's going to be the very same shape as that one. It's going to be right here. And then it just repeats, and it repeats. And it repeats this way too, but we'll use our unit circle here. At negative 3 pi over 4. Here's negative pi over 2. Here's negative 3 pi over 4. It's going to be positive 1. At negative pi, right here, it's going to be 0 divided by negative 1, which is 0. At negative 5 pi over 4, which is up here, it's a negative, or it's positive square root of 2 over 2 over negative square root of 2 over 2, which is negative 1. Okay, so on this part, comes up here, and goes like this. All right, so here's how long, it just takes this far to repeat itself. And I'm going to draw that's what, and notice it goes to the origin. You're on the negative side and the positive side. That's the kind of the parent period of the tangent function. Okay. The period, because notice I went by pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. The period of a tangent function is pi. Every pi units we are repeating. We're repeating. So it is repeatable. And the amplitude it really does not exist. The amplitude, you know, from the midline here, it goes up forever and it goes down forever. These points are kind of significant, though. Those points there are called, it slips my mind. We'll go over that later. Oh, points of inflection. It came back. And we will talk about what those are when we look at when we go specifically to graph tangent and cotangent x. All right, well, let's get the parent function for cotangent. Remember, cotangent is going to be x over y. So, okay, f of x equals cotangent x. I'm going to graph kind of long like it did that last one. And there are going to be asymptotes involved here as well. Let's go pi over 4s again. Pi over 4, pi over 2, 3 pi over 4, pi, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Did I go this far on the other one? 8 pi over 4 is 2 pi. Let's go a little bit over here. Negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. I'm going to stop there. If I have to go further, I will. Okay. Let's draw the asymptotes. I'll draw those in pencil because they're not actually part of the graph. Then we're still going okay, like so. Okay, cotangent is x over y. It's cosine over sine. Okay, so I'm looking at cosine over sine. I can't do that one. That is that's one not going to work. Cosine over sine, that'll work. Cosine over sine at pi, that is not going to work. And at 2 pi, it's not going to work. At negative pi, it's not going to work. So I have an asymptote here, 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 and here, just in what I've drawn along the line here. Okay. The cotangent of pi over 4 is going to be 1. Cotangent of pi over 2 is 0 divided by 1 is 0. Cotangent of 3 pi over 4 is going to be negative over positive, that's negative 1. All right, so we're looking at kind of the same shape as we had with tangent. And this is where it's going to repeat. This is what's going to be rubber stamped all the way across. So I'm going to go 5 pi over 4, 3 pi over 2, 7 pi over 4. I'm going to make this part of the graph like this. And negative pi over 4, just checking real quick, that would be negative 1. Negative pi over 2, that would be 0. Negative 3 pi over 4, that would be positive 1. So I'm just checking my work there real quick. Never mind. All right, so there we go. We got the cotangent. Now look at the cotangent. Let me highlight the main part here. And you can see here that the period here is pi again. And the amplitude, once again, does not exist. No, that was in the frame, was it? Okay, so once you look at the cotangent of x, it's very similar to the tangent of x. Just like sine and cosine are very similar, just, if I were to pick this graph up and move it over, pi over 2 units, I'd have my cosine. Okay, if I take this and flip it this way over the x-axis, or flip it over the y-axis, and then shift it over, I'd have the cotangent. Okay, so I'm wanting you to see that. Now the next one we're going to do is kind of fun to draw. And I'm going to go with f of x equals, I'm going to go with cosecant x. All right, I'm going to draw it kind of big like I did there. Why not? Let's go by 2s. I've given myself enough room here. Or, well, let's do it like this. -1, -2, -3. Okay, now, the first thing I'm going to do is I'm going to draw the sine function. I'm going to label this when I'm done drawing. There's one sine function. So now I went from +1 to -1. I'm going to do that again. Okay. Notice I'm doing this in pencil. This is not the part of the cosecant. I'm going to do it one more time over here. Okay, I'm being very careful on how I draw that. And half, you remember a period is 2 pi. Half of 2 pi is pi. Half of pi is pi over 4. And halfway between pi and is 3 pi over 2. Okay, and then that's 4 pi. Half of 4 pi, or halfway between 4 pi and 2 pi is 3 pi. Halfway between there, that's 4 pi over 2 and 6 pi over 2. That's 5 pi over 2. And 6 pi and 8 pi, that's 7 pi over 2. And then, that's -2 pi. Period on sine is -2 pi. Remember, sine and cosecant are reciprocals of each other. This is -pi. -pi over 2 halfway. Halfway here is -3 pi over 2. Okay. Now here's the next thing. These also have asymptotes because the reciprocal, this is the sine function. Well, here the sine is 0. The reciprocal of 0 is undefined. So I'm going to draw an asymptote here. 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 And I'm going to draw an asymptote here, here, and here. Okay. Now, what I really like for you to think about here is how I just drew that wrong. All right, I got to regroup here. Oh, that's not wrong. There is one thing wrong with it. That's not pi over 4, that's pi over 2. Okay. I just about freaked out for a moment. That's pi over 2. I thought I was going to have to redo this whole line, but make that correction and we're good. So, well, you can't answer this for me to hear you, but the reciprocal of 1. So I want to just take the reciprocal of all these things. Like, the reciprocal of 1 is 1. If I were at pi over 4, I'm going to do a little calculation here. Okay. So if I were at pi over 4, and I were to take the sine, let me get in the right mode here. Okay, I've been doing everything radians. I'm going to keep it in radians. Okay, clear. All right, oops. All right, sine of pi over 4. I just forget what. pi divided by 4. It's 0.7. Now the reciprocal, this x negative 1 is like 1 over, is 1.4. So halfway, we'd be like right around here. And if I do that, it's going to be up here, halfway there. Good with that. And if I get further and further, well, let me tell you just what's going to happen here. This is the actual graph that I'm going to draw. It starts really up high. It starts close to this asymptote, comes down here, it kisses the sine curve, and then goes back up. This is the cosecant function, part of it. This one, it'll kiss right here. It'll come up, kiss the sine curve, and come back down. Come down, kiss the top of the sine curve, come back up. Come up, kiss the bottom of the sine curve, and come back down. And this one comes up, kisses the bottom of the sine curve, and then comes back down to this asymptote. And this one is like this. All right, now a period of the cosecant is from here to here and here to here. These duplicate each time. We replicate here, and then we to here, and here to here. Just kind of move that over. We got this one here. So that is a period. So the period goes from 0 to 2 pi. The period is 2 pi units. Amplitude, once again, does not exist, but the distance from the middle to the curve and the middle of this curve are the same, and that is a significant value when we start graphing and just specifically cosecant curves. All right. One last one. You'll be glad to know, I don't think I'm giving you any bookwork on this one, but let's get the secant curve plotted. I just think a nice day to just kind of set everything up and get this in motion will be good for us here. I'm going to kind of graph the cosecant curve. I kind of like that scale we had before, so I'll go by 2s again, like we did, or not by 2s. I'll go 2 lines per unit. Actually, I'm going to draw these in pen, just for the scales. All right. So, remember the cosine curve. I'm drawing in pencil because that's not, it's just a guideline to help us draw the secant curve. But the cosine goes like this, comes back down, comes back up, and goes like this. And then it'll do that again from here, down, hits down here, and comes back up here. We've already done it, so I'm going to scale after I draw, and you're going to find a lot of what I do is have you draw the general shape when we graph, and then I'll just draw one cycle there. We'll draw the general shape, and then we'll scale it, or then we'll write the scale. Okay, we know this is 2 pi. No, we don't. We know this is 2 pi. Halfway is pi. Okay. I am very sorry. Halfway is right here. This is pi. This is pi over 2. This is 3 pi over 2. What a mess. I hope you can adjust to this, guys. All right, so let's go 4 pi here. Halfway is 3 pi. Halfway between 2 pi and 3 pi is 2.5 pi, which is 5 pi over 2. 3 and 4, halfway between that is 3.5, which is 7 halves, or 7 pi over 2. Okay, let's go negative 2 pi here. Split it in half, that's negative pi here. Split that in half here and here, and we're at negative pi over 2, negative 3 pi over 2. Okay, again, these are just the guidelines, and I want you to look at okay, secant is the reciprocal of cosine. Cosine is graphed. Reciprocal of 0 is non-existent. So I'm drawing asymptotes everywhere on every one of these x-intercepts. Oh. Okay. This curve is just a little bit out of scale here from the way I was drawing it earlier. I don't know why I went so far right there. All right. Well, right here, you come down, you kiss the top of the cosine curve, and you come back up. Start here. You kiss the bottom of the cosine curve and come back down. Kiss the top, come back up. Kiss the bottom, come back down. All right, here I'd start back up. I only got this far. If I go further, I draw that, and I'll draw this one here, and this one here. So the actual secant curve, sorry, is right here. And just remember where it is. And if you remember the cosine curve, you can always just get your sine curve. There's a period, it's 2 pi units. The amplitude is really only relevant with sine and cosine. It doesn't exist. Okay. All right, well, there you go. And that's all we're doing. No homework. Keep those in a safe place. We're going to refer to these a lot. All right, you guys take care and God bless.